Imagine stepping outside tonight. You look up the night sky and it's quiet, it's peaceful. Maybe you see a few familiar constellations up there.
Right, it feels totally still, like this static, silent painting.
Exactly. But you are completely unaware that right at the very moment, Earth is being bombarded. I mean, we were being struck by these incredibly powerful, completely invisible beams of energy.
And they are originating from literally billions of light years away.
Yeah, they're just washing over you, over your house, over the entire planet, and then poof, vanishing into the dark.
It's a staggering image, really. The reality is that the cosmos is fiercely active, you know? It's hitting us with signals that are almost too immense to comprehend, and they just move right through us without us even feeling a thing.
Well, welcome to today's deep dive. Our mission today is to explore the mystery of something called fast radio bursts, or FRBs for short. These things have puzzled astrophysicists for nearly 2 decades now.
But we aren't just looking at the history here.
Right. We are going to examine a recent discovery of a mathematical pattern hidden inside these signals, a pattern that has just completely turned the astronomical world upside down. So, okay, let's unpack this, because the sheer scale of the cosmic mystery we are about to explore is honestly hard to wrap my head around.
The scale is absolutely the foundational piece we need to build on first. I mean, to appreciate why this new mathematical pattern is so shocking to physicists, you really have to understand the baseline.
The normal stuff.
Exactly. We have to look at what a standard fast radio burst actually is, the underlying mechanics of how we even detect them, and just how long they've been driving scientists absolutely up the wall.
So, fast radio bursts were first discovered back in 2007. And almost immediately, they became one of modern astrophysics' greatest riddles. Let's talk about the raw power involved here, because the energy output is just absurd.
Totally absurd.
A standard FRB only lasts for a fraction of a millisecond, right?
A fraction of a millisecond, yeah. Let's put that in human terms. The literal blink of an eye takes about 300 milliseconds. Okay, so we are talking about an event that comes and goes hundreds of times faster than a single blink. It is an incredibly brief window of existence.
Wow. And in that infinitesimal fraction of a second, an FRB releases more energy than our entire sun produces in 3 full days.
Which is just, it's hard to even picture.
I mean, let's just pause and think about the mechanics of our sun for a second.
Okay.
It is a colossal nuclear furnace. The energy it puts out in 1 single second is enough to power all of human civilization for hundreds of thousands of years.
Right.
So taking 3 days of that unbelievable solar output, condensing it, and releasing it all in a fraction of a millisecond. It's like taking the entire history of human energy consumption, multiplying it by 1,000,000, and cramming it into a single microscopic spark.
That's a really good way to visualize it.
But that leads me to a big question. If these things are releasing that much energy in the blink of an eye, how did we only start noticing them in 2007?
Well, what's fascinating here is that the sheer speed of the event is exactly what makes it so elusive, mechanically speaking.
Because they're just too fast.
Yeah, historically, astronomical observation is all about long exposures. You point an optical telescope at a patch of sky, you leave the shutter open, and you gather light particles over hours or, even days.
Right, like those gorgeous deep space photos we always see.
Exactly. But FRBs do not give you time. Furthermore, they are radio waves. They sit on a completely different part of the electromagnetic spectrum, meaning they are completely invisible to the naked eye, or even the most powerful optical telescope.
Wait, really? So you could be staring right at the source of one with a normal telescope and see absolutely nothing?
Nothing at all. You need a highly sensitive radio telescope. And because they flash for a fraction of a millisecond and then disappear, you have to have that dish pointed at the exact precise coordinate of the sky.
At the exact right time?
Yes, at that exact fraction of a second, with computer hardware fast enough to process the burst before it's just gone. If your dish is pointed even a fraction of a degree away, you miss it completely.
Oh, man. It is like trying to catch a photograph of a single lightning strike during a global thunderstorm, but you are only allowed to open the camera shutter for a millionth of a second, and you have to guess which cloud it will come from.
That is a perfect way to visualize it. And that incredibly narrow margin for error, well, it really shaped the early theories. For years, the original consensus in the scientific community was that these were just random, highly rare cosmic events.
Pulse explosion.
Yeah, the underlying assumption was that anything releasing that much energy that quickly had to be a cataclysm. They assumed it was a massive flare-up. Maybe a supermassive star collapsing in on itself, or two incredibly dense objects like neutron stars colliding.
Something that just destroys itself in the process.
Exactly. Something that resulted in a catastrophic explosion that vanished forever into the cosmic dark.
So they were seen as one-and-done events. A star blows up, it releases this burst, and the star is gone. You see it once, and you will never see it again.
Which makes them almost impossible to study systematically. I mean, the scientific method relies on observation and repetition.
Right, you have to test things.
If you cannot predict when or where a flash will happen, you cannot point your instruments there in advance to figure out what's causing it. You are left trying to piece together a puzzle where the pieces keep disappearing before you can even look at them closely.
We had a collection of isolated data points, but no real way to track the underlying mechanism. And that was just the accepted frustrating reality of FRBs until the anomaly changed everything.
It really did.
Because scientists thought FRBs were completely random, isolated events. Discovering one that actually repeats changed the entire paradigm of how we search the cosmos. Enter the game-changer FRB 18091
FRB 18091, the signal that broke all the established rules of radio astronomy.
Unlike those one-and-done cataclysms we were just talking about, this specific signal has a mathematical pattern. I mean, it behaves exactly like a ticking clock.
Yes, it's incredibly precise.
It blasts these incredibly powerful radio pulses at Earth for exactly 4 days. Then it stops. It goes completely, totally silent for exactly 12 days. And then it repeats the exact same cycle.
4 days on, 12 days off.
Over and over again, maintaining a rigid 16-day cycle, like absolute clockwork. But here's where it gets really interesting, because I have to push back on this a little bit.
Sure, go for it.
I know nature has cycles. We have seasons, we have lunar orbits, we have comets that return on highly predictable schedules. But a rigid 16-day on and off switch feels almost too clean for a messy universe. Is it normal for deep space phenomena to be this mathematically precise?
That tension you're feeling, that is exactly what the scientific community is grappling with right now. To you listening, it's crucial to understand that while orbits and rotations are regular, deep space is fundamentally chaotic.
It's messy.
Very messy. Things wobble, orbits degrade over time, environments are filled with cosmic dust, expanding gases, and, gravitational interference from competing bodies.
Right, space isn't a vacuum. I mean, it's full of stuff messing with other stuff.
Exactly the opposite of a sterile environment. So when you detect an exact 16-day schedule, 4 days of intense pulsing, 12 days of absolute silence, and you realize this signal is traveling across billions of light years of messy, chaotic space without losing its perfect rhythm, it forces scientists to completely rethink their models.
Because a natural cycle usually has some noise, some variation.
Exactly. Finding a perfect mathematical rhythm like this in the deep cosmos is like walking through a wild, unkempt forest, and not just finding a perfectly symmetrical garden, but finding a highly engineered automated lighthouse. One that turns its beam on and off with an internal gear ratio that never, ever skips a beat.
It demands an explanation for the mechanics behind it.
The mechanics are the core issue. That demand for mechanical explanation has sparked a massive debate. Faced with this impossible 16-day cosmic clock, the scientific community essentially scrambled.
They needed answers.
Right. They needed a natural explanation, which has led to this massive divide between mainstream astronomers on one side and theoretical physicists on the other.
Okay, let's look at the mainstream view first. Astronomers suggest that the source could be something called a magnetar. What exactly is the mechanism of a magnetar, and how does it explain the ticking clock?
Well, a magnetar is a highly magnetized dead star. When massive stars reach the end of their lives, they run out of nuclear fuel and collapse.
Like a supernova.
Yeah, and sometimes what is left behind is a remarkably dense core, a neutron star with a magnetic field that is trillions of times stronger than Earth's.
Trillions.
Yes. We are talking about a magnetic field so powerful it would rip the iron out of your blood if you got too close. Now, this dead star is spinning rapidly in space.
Okay, so we have a spinning ultramagnetic core. Where does the 16-day cycle come from?
The mainstream hypothesis relies on a concept called precession. The idea is that this spinning, highly magnetized object is not perfectly aligned. It is wobbling on its axis as it rotates.
Like a globe that's tilted.
Exactly. And as it wobbles, it is emitting a fierce beam of radio waves along its magnetic poles. The theory suggests that the physical geometry of this wobble causes the beam to sweep past Earth's field of view on that exact 16-day schedule.
Sort of like a wonky tire on a car. It spins fast, But the tilt of the tire means it only hits the edge of the wheel well at a specific point in its rotation.
Yes, exactly. For 4 days, the angle of the wobble is just right and the beam strikes Earth's general direction, which we detect as pulses.
And then,
Then, the wobble turns the beam away for 12 days, leading to the silence. It provides a natural, mechanical explanation for the rhythm based on observable physics.
that makes logical sense at first glance. It is a cosmic lighthouse that happens to be tilted, so we only see the light when the slow rotation brings it our way.
It's a neat package.
But the theoretical physicists are stepping in and waving a massive red flag here. They argue that a natural object, like a wobbling dead star, simply shouldn't be able to maintain such precise, rigid timing over millions of light years without the signal decaying, shifting, or breaking down over time. Why would the signal break down?
This gets to the heart of the counter-argument. Emitting that sheer amount of energy, remember, 3 days of solar output in a millisecond, has a massive physical cost. You cannot release that much energy without losing mass or angular momentum.
It has to drain the battery, so to speak.
Exactly. If a magnetar is blasting out these incredible forces, the system is actively draining its own energy.
It makes me think of spinning a top on a table. When you first spin a top, it looks perfect. It's upright, the rhythm is tight. Eventually, gravity, friction, the imperfections of the table, they catch up.
Right, can't spin forever.
The top is expending energy to push through the air and spin against the wood. So it has to slow down, it starts to wobble out of its perfect rhythm, the angle shifts, and eventually it just falls over.
A dead star in space might not have a table, but it has competing gravity, and it is losing momentum by emitting these massive bursts. The mathematical models run by theoretical physicists show that if a magnetar were wobbling and emitting this much power, the wobble should decay.
The math doesn't support a perfect clock.
Right. The 16-day cycle should stretch out, shift, or slow down over time. It should not remain a pristine, rigid clock.
So if the math says a natural dead star cannot keep perfect time forever without slowing down or shifting, what are the alternatives?
If we connect this to the bigger picture, we see how the scientific method operates at the very edge of our understanding. When standard natural models like the wobbling dead star fail to fully account for the precision and the lack of decay in the signal, science is forced to look at highly unconventional, paradigm-shifting alternatives.
You have to look outside the box.
You can't just ignore the data because the math doesn't fit the neat box of a magnetar. If the physics suggest a natural object cannot sustain a perfect, non-decaying 16-day energy blast across such immense distances, you have to cross a boundary.
And that boundary crosses straight into the realm of the artificial. Which leads us to the most thrilling part of this entire deep dive.
It really is.
If a natural spinning magnetar cannot fully account for this perfect clockwork, and the signal refuses to decay the way nature demands it should, the alternate hypothesis is that these signals might actually be artificial. We are talking about the alien hypothesis.
It is an incredible leap, but it is a leap completely grounded in the process of elimination. If nature struggles to naturally form a clock this perfect and energetic without it breaking down, you have to logically ask if someone or something built the clock.
And we are not talking about an alien radio station broadcasting music or a simple greeting. The energy scales prohibit that.
Oh, absolutely not.
To explain the math, physicists have proposed two main artificial theories. The first is that these bursts could be the power leakage from giant alien energy grids. The second is that they could be the exhaust, or the propulsion systems, of massive light sails being used for interstellar travel. Let's break those down. First, power leakage from a giant energy grid. How does that even work mechanically?
Well, think about the scale of the energy we established earlier. If this is an artificial energy grid, it is a civilization operating on a galactic scale, potentially utilizing something like a Dyson sphere.
Surrounding a whole star.
Exactly. They would be harnessing the entire power output of stars, routing that unimaginable energy through massive cosmic infrastructure to power whole planetary systems or computational networks.
And what we are detecting, these bursts of radio waves hitting Earth, would just be the sparks flying off the wire, the leakage.
Just the waste energy. When you operate machinery on a stellar scale, the ambient radiation or the accidental misdirection of energy during switching cycles would be colossal. The 16-day cycle could literally just be the operational pulse of their power routing system.
The accidental byproduct of whatever massive machine they have running, that is terrifying and incredible. But the second theory feels even more active, which is the light sail propulsion system. How do you even propel a ship across a galaxy without using traditional fuel?
That brings us to the second hypothesis, which relies on understanding radiation pressure. Instead of using wind to push a canvas sail, you use highly focused beams of energy like massive lasers or radio beams to push a highly reflective sail through the vacuum of space.
It blew my mind to realize they aren't talking about wind sails, but sails pushed by the sheer physical momentum of light. Even though light particles, photons, don't have mass, they carry momentum, right?
That is the exact mechanism. When they hit a reflective surface and bounce off, they transfer that momentum to the object.
That's just wild.
It is. To move a massive ship across a galaxy at a fraction of the speed of light, you cannot carry enough rocket fuel. It would be too heavy. Instead, you leave the power source stationary.
You leave the engine at home.
Yes, you build a massive energy emitter in your home system, and you fire a sustained, incredibly powerful beam of energy against the sail of your ship, pushing it outward into the deep dark.
And this 16-day pattern, 4 days on, 12 days off, could be the operational schedule of that propulsion system. Like a cosmic ferry running on a strict timetable.
Exactly.
They turn the beam on for 4 days to accelerate a departing ship, then power it down for 12 days to recharge or align the next vessel. So what does this all mean? Think about how this changes your perspective.
It shifts everything.
The sheer wonder of walking outside at night, looking up, and realizing that the invisible energy washing over our planet might not just be a random dead star. It might be the engine exhaust of a massive alien spacecraft sweeping across our planet on a precise 16-day schedule. It turns the night sky from a quiet painting into an active, bustling cosmic highway.
This raises an important question for everyone listening. What would it actually mean for humanity if we confirm, beyond a shadow of a doubt, that we are intercepting alien infrastructure?
It would change everything.
How does that change our view of our place in the universe? It is deeply thrilling, but we also have to maintain our scientific rigor. We have to balance the decaying magnetar theory against the physical realities of the light cell theory.
We can't jump to conclusions.
Right. We cannot definitively say it is alien technology, just as we cannot definitively say it is a wobbling star. But the fact that the artificial hypothesis is mathematically and physically viable enough to be debated by serious theoretical physicists in mainstream journals shows just how profound this mystery is.
It's not just science fiction anymore.
No, it's not. Until our own technology catches up to give us a definitive answer, we have to hold both possibilities in our minds, analyzing the physics of each.
Until our tech catches up, these rhythmic signals continue to strike our planet, serving as a reminder that someone or something might be leaving an operational footprint across the cosmic ocean.
It forces us to remain humble. The universe is vastly older, vastly larger, and potentially vastly more complex than we ever dared to assume.
Let's do a quick recap of the incredible journey we've just been on. We started with the discovery back in 2007 of these fast radio bursts, these fleeting flashes of radio waves lasting a fraction of a millisecond, but packing the punch of 3 days of our sun's total nuclear output.
And we thought they were just chaotic, random explosions.
Right. Then everything flipped with FRB 100901, the discovery of a ticking clock. A signal turning on for 4 days, off for 12 days, repeating perfectly without decaying.
Which is just mathematically bizarre.
And this single mathematical anomaly has sparked a massive ongoing debate between mainstream astronomers arguing for wobbling, magnetized dead stars and theoretical physicists pointing out the flaws in that math, opening the door to the staggering possibility of massive alien energy grids or interstellar light sails.
It is a perfect example of how one single pristine piece of data can shatter an entire scientific paradigm. But before we wrap up, there is one more layer to this mystery.
Oh, lay it on us.
We need to consider the implications of the distances involved. These signals are coming from billions of light years away.
Which means, wait, it takes light, or radio waves, a year to travel a single light year. So if they're coming from billions of light years away, these signals took billions of years to actually get here.
That is the haunting reality of astrophysics. The implications of those vast distances mean the precise 16-day schedule we are receiving today was actually generated billions of years ago.
Wow.
Whether FRB 1809 is a naturally wobbling magnetar or the exhaust of a highly advanced alien energy grid, we are essentially listening to a ghost.
We are catching the echoes of an ancient universe. By the time this perfect rhythmic message finally crossed the cosmic ocean and hit our radio telescopes, whatever created it, well, it might have evolved, moved on, or ceased to exist entirely.
Exactly. We are trying to solve a puzzle that might have ended before our own planet even formed.
We are looking deep into the past, reading the fossil record of the cosmos.
It's beautifully tragic in a way.
That is an incredibly powerful thought to leave on. Thank you so much for joining us on this deep dive. We have explored the mechanics of dead stars, the physics of alien light sails, and the ghosts of the deep cosmos. I hope it changes the way you see the stars tonight. Remember, whether it is natural or artificial, the universe is trying to tell us something. Until next time, keep looking up and stay curious.